Hi dear students, welcome back to the spoilage of sugar-based products. In the previous session, we had mentioned about the spoilage of sugars as well as the spoilage of chocolates. Now today we are going to talk about the spoilage of syrups. Among the sugary syrups, we can find that there are mainly three categories. They could be liquid sugar, starch-based sugars, as well as naturally occurring tree saps, like you have maple syrup or the starches of multiple origin. Now for example, you have potato, corn, wheat, etc. All these could result in the formation of various sugary syrups. And these syrups are being used in a variety of products. Now in the food industry, you can find them. They can be used as confectionaries, in beverages, bakery, ice creams, jams, jellies, as well as sometimes even in some meat products also, some sugary syrups could be added to get a flavor for the gravy. Now the addition of water to such refined sugar to produce a liquid sugar produces an ingredient that will be most susceptible to the microbial spoilage. We know that when the water is being minimum in a sugar, the chances of spoilage which caused by the microbes is being found to be less. So when you add some water to get a syrup, what happens? The chances of microbial spoilage of the syrup is increasing. And the water activity of a liquid sugar is at a level that makes it prone to yeast as well as the malt growth. You can have Saccharomyces roxy as well as Saccharomyces cerevisiae and Saccharomyces mellis as well as various malts which are capable of growing in sugar. Now the former three ones which we told, these are yeasts which are capable of rapid growth in the case of liquid sugar syrups. And when these microbes will grow, they mainly depend upon the level of contamination, the availability of the non-sucrose nutrients as well as the gradients with high water activities within the substrate materials. Usually in normal conditions, yeast multiplies at a very faster rate and whether they have to be present here or whether they grow at beyond a level, it mainly depends upon how contaminated or how much amount of these yeast as well as malts are being present in the sugar syrup. And also various other non-sucrose, if there are various other non-sucrose nutrients present there, or if there is any gradient in the high water activity, etc. These all will influence the growth of these yeast as well as molds in the sugar syrups. Now you can see that different spoilage microbes can be found in the syrups. If you go to check into maple syrup, you can see Saccharomyces roxy as well as Saccharomyces cerevisiae as well as Saccharomyces mellis is being present. And honey is also a type of, though it is not truly syrupy, but you can see even in them you can find spoilage microbes like Saccharomyces roxy, Japonicus, Berkeri, mellis, etc. And in the moistened white crystalline sucrose, you can have Torulopsis apicola, and in the raw sugar you can have here Saccharomyces roxy, Tropicola, Torulopsis candida. Then table syrups can have molds, canned syrups can have Saccharomyces roxy, and different types of yeast as well as malts are being present here. So you can notice one thing, in the case of syrupy things, it's more of yeast and molds rather than the bacteria which is being present. And how do we prevent the spoilage of such syrupy solutions? The microbial spoilage of sugar syrups can be controlled by either removing or inactivating the microbes capable of growing in these syrups. You can properly clean as well as sanitizing the equipment, as well as also prevent the development of condensates as a result of the microbial growth. So first itself you need to inactivate the microbes or prevent their growth, or you can properly clean or sanitize the equipment which we are using for the preparation of these syrup solutions. Of course, the water which has been present here, which is being used for making the syrup, should be sterile, And the microorganisms associated with the equipments, now for example the tanks, pipes, valves could be controlled with heat or chlorine, and their growth can be prevented by applying persistent iodophos to the equipment. So all the equipments which we are using in the syrup preparation are being found to be tried to maintained in a microbe free or a microbe limited condition using the principles of heat as well as chlorine. And the liquid sugar, this can also be filtered to remove the microorganisms, and it can be heated or exposed to ultraviolet lamps to kill the microorganisms that may be present. You know what is the purpose of filtering it? You will use a filter which will remove the microbes, probably something of like a 0.2 micrometer filter. So but you remember, when it comes to more viscous fluids, it's not easy to pass through a 0.2 micrometer filter. So it depends upon the consistency of the liquid sugar which we can use a filter or not. So some cases you might also heat it, like we had previously mentioned in the case of sugar. When cane sugar was being extracted, you can heat it, or another option is you can expose it to UV lamps to kill the microorganisms that could be present. But I need to tell you something, the effectiveness of the UV lamp base of sterilization also varies, because not to full length the UV lamp can go, or you can use a multi-combinational method also. But the ultimate aim that we have here in the sugar syrup, in the prevention of sugar syrup, is that you need to reduce the microbial contamination in the sugar syrup, because coming into contact with the sugar syrup is just like getting a heaven for its growth. So the best way is to prevent the entry of these microbes into the sugar syrups by using well containment techniques, such as using equipments which are being cleansed or sterilized by using heat, chlorine, etc. and all that. I hope this is clear to you. With this we come to an end of the spoilage of the sugary syrups. We'll be continuing into one more session on the spoilage of the sugary components. Thank you for now.